In this circuit diagram, we're asked to find V0, which is this value right here, and we need to use the mesh current method to find the V0 in our circuit diagram. So when I'm looking for the mesh current method, I'm going to be drawing a direction of our current for each of these individual parts. We're going to have three parts. We have this bottom part. This is going to be our I1. We also have another part just to the right of it, which is this right here. This is going to be our I2. And then lastly, we have this upper part up here, which is going to be our I3. So we have three different parts, and this is for Kirchhoff's voltage law. We're going to find the part for our I1. In our I1, we have this voltage right here. It is a 25 volts going in the opposite direction of our current. So we're going to have a negative 25 volts. Now we're going to solve for our I1. Our I1 is our 6 ohms plus 8 ohm resistors. So we are going to have a plus 14 ohms, and this is for I1. Our 6 ohm resistor is with our I3. They share currents. Our I1 is going to the right, our I3 is going to the left. So we're going to have to do a minus 6 ohms, and this is for our I3. And we're going to do the same for the 8 ohm resistor because it's with our I2. So we're going to do a minus 8 ohms, I2. And this is all set equal to 0. I'm going to solve for our I2 now. So for our I2, we're going to add all of our resistors right here, our 8 ohm and our 8 ohm resistor. This is going to give us a 16 ohms for our I2. We're going to have to subtract 8 ohms for I1 and 8 ohms for I3 because they are in opposite directions on their side. Lastly, we have this part right here. We can see that it's going to be going into the positive out of the negative, so it's going in the same direction as our current flow. So we're going to have a plus here. In our plus, we'll have a 5 I0, and that's equal to 0. Now we have to solve for our I0. Our I0 is over here, and it's going the same direction as our I1. Since it's going the same direction as our I1 inside of this closed circuit part right here, that means that our I0 is equivalent to I1. So we can just substitute our I1 into the I0, and we can add this to our other I0. If we add this and this together, we're going to get negative 3 ohms I1. Lastly, we are going to solve for our I3. For our I3, we're going to add the resistors here. We're going to have 16 ohms of resistance for our I3. We're going to have to subtract the 6 ohms because of our I1 and subtract 8 ohms because of our I2. We don't have any voltages or anything weird in here, so that's it, just set equal to 0. Now I'm going to rewrite these and then get ready to plug it into a matrix. After do that, we're going to get all of these right here. This first column is for our I1s, this next column is for our I2s, and this last column is for our I3s, and then we have the constants to the right. Before we plug this in, I'm going to substitute our I1s for X, our I2s for Y, and our I3s for Z. Once we plug this into a matrix calculator, I'll have one link below. We're going to get these values here. Now we need to find our V0. We know that our V0 is going to be equal to the current times resistance. We know our resistance to be 8 ohms, so now we just got to find current. Our current, I, is equal to our I of 1, because our I of 1 is going this way and our voltage is going this way. But it's also next to our I of 2, which is going this way. So we are going to have to subtract from our I1 our I2. And we know that our I2 is equal to our Y. That's what we substituted this in for. So this is our I2. And we know our I1 is our X. This is what we substituted that in for. That's going to be a 4. So we're really having I is equal to 4 minus 2, which is 2. So we're going to have 2 times 8, and that's going to give us 16. So our answer for V0 is 16 volts. That is how you do this problem. If you want more problems like this, there'll be a playlist linked below with a bunch of intro to circuit analysis problems, as well as notes that can help with these and study for an exam.